Okay, I'm back with another video about neural style transfer. So it's another Python notebook that I run on a Google Colab, and I think it's a pretty good implementation because it has the TV regularization loss term, which is important in order to avoid getting all those dots, tiny dots, high frequency artifacts. So of course I'm going to put the link to this guy in the description, in the video description. So let's see what it looks like. So basically what you do is that you put here, so what you do is that you upload content, and here I put a bunch of styles. So I did 8 styles, and that's the output. So let's see, where does it define? Okay, so this is the content path and the style path. All you have to do, upload your image and put the path. So to get the proper path, what you do is that you go here, you click here, and you say copy path, and then you go here and you do Ctrl V. Same for the style. So I did each style. Here I just finished style 7. So what that thing does, you can visualize the input just to make sure it's correct. Then it does this, I'm not sure why. That's TensorFlow hub model, I don't know what that is, but it gives you this. I guess it's just a reference, something to compare with, I don't know. Then he loads the VGG19, which is the neural network, and this shows all the layers of that network. So here you have to choose your content layers and your style layers. By default is using conv1 here, conv1, 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 conv1 for each block. I think you get better results using conv2. So conv2, that's what I changed here. Conv2, I use conv2. Otherwise I didn't change anything. This is pretty normal. So the content layers, yeah, block you only use one, and for the style you use all of them usually at each block. So that's fine, except I use conv2 instead of conv1 here. You can try conv1, but I think you get better results with conv2. Okay, so he builds the model. Then, so I already run it, of course. So on content and style 7. So then, yeah, so now it's ready to run. So this is the important bit. You have the style weight and the content weight. I didn't change it because I think he's probably tuned it. So he's using style weight 0.01, and for the content weight he's using 10,000. I didn't change that. I think it's fine, but you can certainly try and change it. So now he's just doing a test run to make sure it's correct, and now he's doing the stuff. So here epochs, steps per epoch, that controls your number of iteration. So it means here I'm gonna have 10 times 100, 1000 iterations. You can try to put more or less or fewer. Okay, so this is the result without the TV loss, So what happens that if you don't use a TV loss term, you get dots. You get dots all over the place, tiny dots, high frequency stuff. And actually he's showing he found like a visual way to explain that. So here he's showing basically the edges in the image, the input image. So this is the input, the content image. So here you can see clearly the outline basically. So you have the horizontal and the vertical. So the horizontal deltas are going to catch the horizontal lines, and the vertical deltas are going to catch the vertical lines, which you can clearly see here. The problem is that, okay, so this is the output, and as you can see, you are picking up a lot of crap. That you don't want that. You get lots of artifacts. That's what you want to get rid of. The here is doing Sobel edges. I'm not sure why. It doesn't really matter. So now he's adding the regularization loss, the TV. It's called a TV, the TV loss, total variation loss, TV regularization. It has different names, but basically what it does is that it kind of smooths out the result. So you should get fewer high frequency artifacts. So what it does is rerun the whole thing with the TV loss now. And the weight to control, this is the weight of the TV loss, total variation. It puts at 30. I leave it here at 30. You can try a smaller or larger number. If you put a larger number or a number that's too large, what's going to happen is that the whole image is going to be smooth. You don't want that either, but you want some weight to it. But 30, I think it's okay. So you rerun, and that's what you get. So as you can see, you kind of get rid of the high frequency artifacts. You still keep the texture of your style, but the problem is that here, for instance, there's a lot of smoothing that has happened here in that corner, and that I don't really like. So there's a trade-off. What you want is to get rid of all those very high frequency artifacts, but you don't want to lose those edges coming from the texture, okay? Because that kind of defeats the purpose. And then he saves the result, and the result is saved here, stylized image. So what I did is that I run that thing on those 8 styles, and now I'm going to show the results in GIMP. So okay, so this is GIMP. So this is my content. And this guy, I wonder if this is Mick Fleetwood, the guy from Fleetwood Mac. Kind of looks like him. So anyway, so that's your content, and now I'm going to show you the styles. So I use this style, first style, no, then the next style. All my styles are abstract painting with a lot of impasto, so texture, a lot of texture. So visible brush marks, knife marks, whatever. I like that, and I want the style to transfer correctly. So another style, another style, another style, okay. So lots of texture, and that one. So let's look at the result in order. So that's the first one. So that's the first style. So this is with the TV loss, and this is without the TV loss. So without TV loss you get dots, and with TV loss, if you use TV loss, you don't get the dots, but you get smoothing, sometimes too much. In this case, too much. So this one is not very good. So let's go to the next one. So that's the next style. So maybe I'll show the first one. So this is without the TV loss. So as you can see, you get lots of artifacts. And with TV loss. So I think this one looks quite good. Okay, next one. Okay, so without TV loss, again you get those dots all over the place, but it's relatively sharp otherwise. Then with the TV loss, that's what you get. Okay, again, smoothing, too much smoothing has occurred here, probably too much here. You still get the texture, but you kind of lose some. Okay, next one. So this is without the TV loss term. So here you get some high frequency artifacts, but I think the result is quite good without the TV loss term. If you add the TV loss term, you get this, which is okay, which is fine. You get rid of some artifacts, high frequency artifacts, which is always good. Okay, so where am I now? Okay, so next one. Okay, so without the TV loss term, again you get dots all over the place. If you use with the TV loss term, very nice. You get some smoothing, like here, the beard, but it's, I mean, it's a trade-off between you know, getting rid of the high frequency artifacts and smoothing too much. Okay, so next one is this one. So let's do without the TV loss. Here you get a lot of artifacts, dots. With TV loss, you get this. So you still get some text, the texture comes through, but quite a bit of smoothing has occurred. And the last one. So without TV loss and with TV loss. Looks pretty good to me. Okay, so now let's go back to the Python notebook. What I'm gonna try is change the size of the output. I want to, because right now the output size is 512 by 512, and all my input is the same size, 1024 by 1024, everything. And so right now the output is 512 by 512. I would like the output to be 1024 by 1024. So I'm gonna try that, and I'll be right back. Okay, I'm back. So what I did is that first of all I changed the number of epochs from 10 to 20. So all you do is use find and replace, or you just click on where you want to change and you change it manually, which is what I did. So 20, and I also changed the number of iteration. No, not the maximum dimension, which used to be 512, so now it's 1024. So same idea, you look for it and you change it manually. So here, max dimension 1024. Okay. So then I run the content using style 7. So let's see what happens without changing anything else. So this is the 512. So this is with TV loss, without TV loss. Okay, have a good look at it, because let's see what happens when you do 1024. Completely different. So this is without TV loss. Okay, let's compare without the TV loss. So this is the 512 and this is the bigger one. Okay, so that's the bigger one. So you can do it, it takes longer. You can definitely do bigger images. How long does it take? Let's see, you may ask. How long does it take? it takes 700 seconds, which is what, 10 minutes. So it's not bad. The problem is the when you have the TV loss in without changing anything else. Now it's completely blurred, meaning that the weight is too much. So it's kind of a pain in the ass, because now you have to worry about the size. Apparently the size affects the as an effect on the output. So now you have to worry about the weights. So the weights now depend on the size of the output. So that's a bit of a pain. But you can see you definitely have too much weight on the TV loss. So you would have to reduce it. Instead of 30, put 3 and run again. Well, you get the idea. I think it's a pretty good implementation. The best implementation is still the original Justin Johnson implementation on GitHub, but you have to run it on your own computer. Because with Justin Johnson, I don't think you even need TV regularization. It doesn't create those dots, so I don't know. Okay, so all in all, I give this implementation, I don't know, 4 thumbs up out of 5. It's not bad at all. Note that my goal is to transfer like abstract, heavily textured painting, to transfer that to the content image. So my requirements are set pretty high, I guess. Okay, so anyway, if you like this kind of video, please like, comment, subscribe, and I'll make more. Until then, see you around. Bye.